Welcome to this architectural deep dive into agentic AI. Today, we are moving beyond simple linear pipelines to explore hierarchical agentic orchestration. Traditional automation follows a rigid path, but agentic workflows leverage large language models to reason, iterate, and adapt. In a hierarchical structure, we utilize a manager agent to supervise specialized worker agents. This approach solves the reliability gap in complex enterprise-level tasks. Step 1. Define the supervisor agent. This agent acts as the brain of the operation. Its primary responsibility is not execution, but decomposition. When a high-level request arrives, the supervisor analyzes the intent and breaks it down into granular subtasks. It maintains a global state and decides which specialized worker is best suited for each segment of the job. This ensures focus, structure, and operational clarity now. Step 2. Implement specialized worker agents. Unlike general-purpose bots, these agents are constrained by specific tools and system prompts. For instance, you might have a search agent with access to web APIs, a coder agent for execution, and a reviewer agent for compliance. By limiting their scope, we reduce hallucinations and increase deterministic output. This specialization is the cornerstone of reliable architecture. We must maintain these boundaries to ensure system stability and high-performance results. Step 3. Establish the communication protocol. Communication between agents must be structured. We use a standardized JSON-based schema to pass data between the supervisor and workers. This ensures that the state is preserved as the workflow progresses. Each worker completes its task and returns a status and result payload. This uniform structure allows for seamless integration across different agent types and model versions. Step 4. The evaluation and self-correction loop. This is where the magic of agentic AI truly happens. Once a worker submits its output, the supervisor routes the output to an evaluator agent. This agent checks the result against the original requirements. If the output contains errors, the evaluator generates a critique. The supervisor then sends the task back to the original worker with this feedback. This loop continues until the quality threshold is met, ensuring high-fidelity results. Step 5. State management and logging. In a production environment, you must track every turn of the conversation. We implement a persistent state store to record the history of agent interactions. This is critical for debugging and for resume-on failure capabilities. If an API call fails, the system can inspect the state and restart from the last successful checkpoint. This ensures high availability and robustness for mission-critical applications. Step 6. Deployment and scaling. Deploying these agents requires a microservices architecture. Each agent should run in a containerized environment to ensure isolation. We use an orchestrator like Kubernetes to scale worker nodes based on the volume of incoming requests. This ensures that a surge in complex queries does not bottleneck the entire system. Proper monitoring must also be configured to track agent performance and latency. To summarize, hierarchical agentic orchestration transforms AI from a simple chatbot into a resilient, self-correcting workforce. By separating reasoning from execution and implementing strict evaluation loops, we create systems that handle ambiguity and deliver reliability. This is the future of cloud-native automation. Thank you for joining me. Start building your multi-agent systems today to unlock the potential of the agentic era. The journey from static scripts to dynamic agents begins with a single hierarchy. Focus on the modularity of your workers and the logic of your supervisor to build a system that is powerful, maintainable, and truly scalable. Mastering this allows developers to achieve automation with precision today.